Hello everybody, today I can prepare for my similar triangles test by practicing. So basically on the review sheet there is 2 of every type of question that will be on the test. In this video I will only go over the odds, but you can always access the key and the older videos for more examples gone over. Triangle sun has coordinates, so I am going to start by plotting those coordinates. S is 0, 6. U is 3, 5. N is 3, 0. And it wants me to dilate it by 2, centered at negative 1, 4. So let's get negative 1, 4 on here. And it wants me to dilate it by 2. So to dilate a point, I count from the center to each point, and I do that this many times, whatever the scale factor of the dilation is. So I'm going to start with S. To get from the center of dilation to S, I'm going right 1 and up 2. So I'm going to go right 1 and up 2 twice. Right 1, up 2, that's 1. Right 1, up 2, that's 2. That's S prime. Now, we're counting from the center. So to the original point counts as 1, so then I only go 1 more from there. I'm not counting 2 from S, I'm counting 2 from the center. U, from the center to U is 1, 2, 3, 4, 1. Right 4, up 1. Do that twice. From the center, 1, 2, 3, 4, 1, 1. 1, 2, 3, 4, 1, 2. And finally, N, I count from the center to N. 1, 2, 3, 4. 1, 2, 3, 4. Do that 2 times. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We connect them. And once we do that, we'll make sure you look at it and make sure it looks correct, because if you made a mistake, it's likely you'll see it. Did it look like it was multiplied by 2, is dilated by 2, centered at that point? Yes. And again, this was the center of dilation. Yes, it looks good to me. Another way to check it, if you draw a line from the center, it should go through both the point and its image. So that checks out, that checks out, and that checks out. So to dilate points, count from the center of dilation to each point, and do that this many times. The number of times is the scale factor. So number 2 is more practice with that. Number 3, determine whether the following triangles are similar. So here's what you need to know for this. You need to know that the corresponding angles of similar triangles are congruent. The corresponding sides of similar triangles are in proportion. Within that, there are 3 methods for showing triangles are similar. There's SSS, SAS, and AA. SSS means that 3 pairs of corresponding sides are in proportion. SAS means 2 pairs of corresponding sides are in proportion and the angle between them are congruent. And AA means that 2 pairs of angles are congruent. To prove triangles similar, AA is the only method for statements, reasons, proofs, but to show it, either one of those 3. So based on what they give me here, it looks like I'm using SSS. Now I need to see if the triangles, if the sides are in proportion by creating proportions. So the 2 is going to go over the 6, because those correspond. The 4 goes over the 8, because those correspond. The 8 goes over the 12, because they correspond. So now you need to reduce each of them. If you can't reduce fractions on your own, basically you're looking for a common factor. What goes into both 2 and 6? Well, 2 does. So divide each of them by 2. I get 1/3. I can do that same procedure here. 4/8 reduces to 1/2, and this one reduces to 2/3. So are the sides in proportion? Do they all have the same ratio? No. No. My explanation, the sides are the corresponding sides are not in proportion. If they were, you would say yes. The short answer would be SSS. The long answer would be yes. It has 3 pairs of corresponding sides that are in proportion. And again, if you want to practice this more, look up this lesson, but I'm not going to go over every problem. Number 5. It's saying that a sequence of rigid motions maps A, B, C, D onto J, K, L, M. So this is the only question on this test that's not, well, one of the only questions that's not similar triangles, because it's a sequence of rigid motions, it means that they're congruent. Now, I don't like these pictures, so I'm going to draw my own A, B, C, D, and J, K, L, M. And they don't have to look like the originals. I'm just going to make them very nice and easy to follow. A, B, C, D, J, K, L, M. So, which of the following must be true? Well, we're going to see which corresponds and which don't. L and B do not correspond. A and J do. Just do a different color. JK, AC, JK, AC do not correspond. And JM, AB do not correspond. Choice 2 is the answer. All right, if you have triangles congruent, draw your own triangles. Once you draw your own triangles, or in this case quadrilaterals, you just have to see which matches up. Number 6, these are overlapping similar triangles. They're not candy corn problems because they're not parallel, so I'm going to draw my triangles separately. So I'm going to start by drawing the big one, and then I'm going to draw the small one, but I'm going to make it look just like the big one. Now the tricky part is determining what corresponds to what. So it's telling me that E and L are congruent. Remember, the vertex is always the middle letter. So that means that if this here is L, then E must correspond to that. Now, looking at the picture, A is reflexive, so A is in both, so A is going to correspond to A, and the only letter that's left in the small triangle is N. That's probably the trickiest part of the problem, is getting the letters in the right spot. Now, let's start putting the information into both pictures. AE is 6, ES is 12. Now, I don't see ES in either of these triangles, but if ES is 12, that makes AS 6 plus 12, which is 18. ES is congruent to AL, so if ES is 12, then AL is 12. And it wants NL. Well, NL would be right here. So let's find, I'm just trying to see what's here. So I can find AN, I call this Y, then I can find AL. So now that I have this, I put my corresponding sides on top of each other. I'm going to put 12 over 6. I'm going to put 18 over Y. Cross multiply. 12Y equals 108. Divide by 12. Y equals 9. So if AN is 9, if this whole thing is 12 and this piece is 9, then NL must be 3. So that one definitely had some little twists, but when you have overlapping triangles, draw them separately and use clues to see what letters go where. And make sure the triangles look the same. For any question that you separate the triangles, you want to make sure those two triangles look the same, and then just deal with getting the letters in the right spot. Again, E and L, it told me corresponded, and since A was reflexive, that had to be in both, so those had to correspond. 9, midpoints. When the midpoints are joined, 2 times the midsegment equals the opposite side. That's the rule that you need for these. Or in other words, the midsegment is half of the opposite side. Now, a little twist at the beginning of this question. It says that the perimeter is 36 and that it's equilateral. So since it's equilateral, all the sides are the same. So if the perimeter is 36, it means that each side is 12. Now it's asking for EF. Since EF is a midsegment, it must be half of the opposite side. So if that opposite side is 12, EF is 6. And that's your answer. The midsegment is half of the opposite side. This midsegment must be half of this. This midsegment must be half of this. It's half of the side that it's parallel to, and the key for knowing to use this rule is when it talks about midpoints within triangles. 11, Hill-Sass. You got to recognize this picture. This is your Hill-Sass picture. It looks like a big hill. So BD is 2, DC is 10. We have that. It's asking for AB. Hills or Sass? Well, you need to know that this is H. This is the hypotenuse, leg. The altitude is drawn, and the hypotenuse is broken into 2 segments. So, is there an L involved or an A involved? Well, the A is blank in this example, the L is not, therefore I'm using hills. So it's H over L equals L over S. H is this whole thing, which is 12, over L is X equals L is X over S. Well, there's 2 S's, but since I'm using the left leg, I'm using the left seg, which is 2. Once I have my proportion, I cross multiply, x squared equals 24, and solve. Now, since I don't see radical 24 there, I have to reduce my radical, which we spend time doing. So I list my perfect squares. And I'm looking for the largest perfect square that goes into 24. 24 would go there. I can't divide 24 by 16. I can't divide 24 by 9. I can divide it by 4. 4 times 6. 2 rad 6. If you don't know how to reduce radicals, go back and watch that video because you need to be able to reduce the radicals. Choice 3 is your answer. To determine if a proportion is true, first of all, just like a couple of the earlier problems, I don't like this picture, so I'm going to draw my own pictures using these letters. A, E, C, B, E, D. So, to determine if a proportion is correct, I'm looking at the letters vertically and horizontally. One direction should be in the same triangle, the other direction should correspond. So, CE and EB. Are they in the same triangle? No. Do they correspond? No. That one is not true. EC, BE. EC, BE. which is the same thing we just did. Are they in the same triangle? No. Do they correspond? No. AE, AC. AE, AC. Are they in the same triangle? Yes. So far, so good. So now the other direction should correspond. AE, BE. Do they correspond? Yes. That one checks out. Let's try the last choice. ED, AC. ED, AC. Are they in the same triangle? No. Do they correspond? No. That one's out. The answer is choice 3. Look at the letters vertically and horizontally. One direction should correspond. One direction should be in the same triangle. Candy corn bases separates. Let's see. I see a candy corn. AB is 10. AD is 8. AE is 12. What is EC? Let's play our candy corn song. Let's go to our Common Core geometry songs. Candy corn problems. Candy corn bases separate if there are no bases. Put the top over top, side over side, and the bottom over bottom. Candy corn bases separate if there are no bases. Put the top over top, side over side, and the bottom over bottom. Yeah. So, candy corn bases separates. Are the bases involved here? No. If there are no bases, put the top over top. Do I have both tops? Yes. The side over side. Do I have both full sides? I have the 10. I don't quite have that full side there. And the bottom over bottom. Do I have both bottoms? I have X there. I don't quite have that. So you have two options. You can either add to find the whole sides or subtract to find the bottoms. I think it's easier in this case to subtract on my left-hand side. If this whole thing is 10 and this is 8, then this piece must be 2. Now that I have both bottoms, I put the bottom over the bottom. You put your top over your top, your side over your side, your bottom over your bottom. We could have also done 8 over 12 equals 10 over. This whole side would be x plus 12. That would work as well, but I'm not going to do it that way. I think it's easier to have subtracted. From here, we cross multiply and solve. 8x equals 24. Divide by 8. X is 3. EC is what I was trying to find. EC is 3. I'm just going to, I know I said I'll only do the odds, but I'll make an exception here because candy corn problems are very different if the bases are involved or not involved. So because this one's asking for from B to C, candy corn bases separate. The bases are involved, so I'm going to separate my triangles. I'm going to try and draw them as neatly as possible. ADE is the small one, and ABC is the large one. So expect to have to add or subtract something for these. This whole thing is 230 plus 85, which is 315. So the small one's usually easier to deal with. I got 230 for AE. I've got 120 for DE. AC is 315, and BC is X. Now that I have that, it's pretty simple to create my proportion, put the corresponding pieces on top of each other. 120 over x equals 230 over 315. From here we cross multiply and solve. 230 times x is 230x. 120 times 315 is 37,800. Divide both sides by 230. X equals to the nearest yard, 164. So if the bases are involved, like this problem, then separate your triangles. If not, then you put your top over your top, your side over your side, or your bottom over your bottom, depending on the information that they give you. Describe a sequence of transformations. Identify the transformations. Translate, rotate, reflect, check for orientation. Check for orientation to see if there's a reflection or not. Remember, the only one that does not preserve orientation is reflections. A, D, E, A, B, C. This one, ADE, is going clockwise. ABC is going counter. So since it has opposite orientation, I know that there must be a reflection. So since we're off the grid, we need them to be touching. They are touching right now, so I don't have to worry about translating. I'm going to start by reflecting. I'm reflecting triangle ADE over, well, the side that's touching is AE or AC. It doesn't matter. So let's kind of do that. And because it says ADE onto ABC, that's why I have to start with ADE. So if I reflect ADE over AE, it's going to look something like that. Followed by, well, it's way too small. I have to make it bigger. To make it bigger, I do a dilation. You need to be very specific with your dilation. Followed by dilating triangle ADE by a scale factor of, now scale factor equals image over original. So, being how there's no numbers here, we have to use segments. It doesn't matter which segments we use. I'm going to use the one up here. So the image is, let's just make the whole triangle black, is the black one. So AB is the image, and the original would be AD. Now, instead of AB and AD, you could have said BC and DE. You could have said AC and AE. Either one is fine. So I'm going with a scale factor of AB over AD. Centered at, well, the center of dilation is always the invariant point, the point that didn't move. The point that didn't move was point 3. What is the relationship between the triangles? Well, since there was a dilation, they're not congruent, but they are similar. So I can say that a reflection and dilation preserve angle measure producing a similar figure. So the answer is they're similar. So make sure you kind of answer that. So, I mean, look back at this lesson. This was at the beginning. This was like the third lesson in this unit. Sequence of similar transformations. Always check for orientation first to see if there's going to be a reflection or a rotation. If the orientation is different, there's going to be a reflection. So I did the reflection first. Then I dilated it. Make sure you're very specific. Tell me what you're dilating, what the scale factor is, which is always image over original, and what the center of dilation is. Step 2 is always a blank and a dilation, preserve angle measure, producing a similar figure. All right, we're almost done. Proving multiplication. Well, we have another song for this, so let's hear our similar triangle proof song.
Similar A, similar A, similar A, backwards when you have proportions is the step, multiply CPE, proportions is the step, multiply CPE, proportions is the step, multiply CPE, proportions is the step, and multiply CPE.
Yeah, one of my favorites. So we're going to go through this. Whenever you're proving multiplication or proportion, we want to start to work backwards. So I'm going to start from the bottom. SC times OU equals OT times SU. And the reason is always CPE, which stands for cross products are equal. All right, now before the multiplication always comes the proportion. So we're going to start with a blank proportion. Whatever's being multiplied, let's go diagonal from each other. So SC and OU should be diagonal from each other, and OT and SU should be diagonal from each other. The reason for the proportion is CSS tip, and CSS tip is fine. What CSS tip stands for is corresponding sides of similar triangles are in proportion, which means before the proportion is similar triangles. Is it obvious which triangles are proving similar here? It is pretty obvious to me. I've got this big one, SCU, and then I've got the small one. I'll do a different color for that one. And just be careful what corresponds to what here. C and T corresponds, so T is in the middle, OT. The reason for that is AA. That's how it ends. Now I know that I have to prove that those two triangles are similar. So I'm going to kind of start at the beginning. I'm not doing too good on space here. Statements, reasons. Now from here, it's just your knowledge of proofs. Angle C is congruent to angle OTU. That's given. That's one pair of angles. That's a gift. There's no more given, so I go on to my additional tools. VRIAS. V, vertical angles. Nope, there's no vertical angles here. There's no X. Remember, vertical angles are formed when you have an X, when you have intersecting lines. Reflexive property, is there a side or an angle that's in both the blue and the purple triangle? Yes. Angle U is in both. So angle TUO is congruent to angle TUO. Reflexive property. So I have my two pairs of angles, so I can fill in the rest. Whenever you're being asked to prove proportions or multiplication, it always ends the exact same way. It always ends exactly like this. The reasons will always be completely identical, and my statements are going to always be the same, just different letters, of course, depending on the problem. You don't need to understand proofs to do the bottom, and you pretty much half the points you're getting in the bottom. So that's it. I mean, again, the main understandings, the main conceptual understandings of this unit of similar triangles, the corresponding sides are in proportion. So that's why you're always creating proportions. And the corresponding angles are congruent, which is why when we're doing proofs, we're proving angles congruent. Practice, practice, practice. If you practice, you will do much better than if you don't practice. So it's up to you how much time you want to put in. In addition to this video, we also have, all the other videos and keys. So you have plenty and plenty of resources to use to prepare for your exam. I hope you prepare for it. Have a great day.